Hi, I'm Jason Huckabee for Team 45. Going to be going over our artifact deliverable. Our project was utilizing AI vision techniques to monitor pilot activity inside the cockpit. Our final goal is to be able to train a neural network to input a video of pilot in a cockpit and predict his actions based on his movements in the cockpit. It's very early in the stages of this, so we are just trying to demonstrate TensorFlow and training a neural network with just some simple calculations here. So I'm going to share my screen, and this is our deliverable. I'll go over the inputs first. This is our training set. So we have 10,000 lines with, or 10,000 rows, 4 columns. The first 2 numbers in the column represent the numbers to be added or subtracted. The third number in the column is the result of the addition or subtraction. And the fourth is just a bit or Boolean value, 0 or 1, 0 for subtraction, 1 for addition. So we will run this into our model to train it. This is, I believe, 10,000 rows. Yeah, it is. And after that, hopefully, we'll send it some test data and let it predict whether these first 2 numbers are additions or subtraction based on the first 2 numbers. Well, the first 3. And this one's much smaller, 1,000 rows. But let's get to the model. So we were originally just testing this with individual inputs that we would do ourselves. So we would have it say we think it's addition or think it's subtraction. We are not doing that anymore. Here we're inputting the training data. So this file train, we're inputting into a variable here and turning it into NumPy arrays. NumPy arrays are extremely convenient for neural networks. Python supports this technique called broadcasting that really cuts back the number of iterations. You delete 2 for loops, so you really speed up the process. I think without that, this would be unbelievably slow. So here is the actual building of the model itself. This is TensorFlow. We're using a package called Keras. It's pretty simple. It's working great for our artifact, just our preliminary design here. Sequential, I think that's designed for a single input and a single output. So if this was something more challenging to identify, like multiple motions inside the cockpit, this wouldn't work. But for now, just to demonstrate that we have implemented TensorFlow, that's what we're using. So this particular model here has 4 layers. Each row here represents a layer inside the neural network. The first number represents the number of nodes in each layer. So say this one, the first layer has 64, then 32, then 16, and then finally the 1, which is the output layer. This is the activation function here, ReLU. It's just a pretty standard activation function. It will be what calculates, it does a bunch of math behind the scenes, which you don't see here. It's very convenient that it does it for you. So the last one, we're using sigmoid. You have to use a sigmoid on the last one because it outputs integer values, 0 or 1, which we need. Like, is it addition or subtraction, true or false? And we are training the model here. We are timing it with a start and a finish. We're just throwing the training data in here. This first part is our loss function, which it will train itself to get closer and closer to the actual value that is the answer. And going down, this is just the test data. We're doing the same thing we did for the training set. Inputting it, turning it into NumPy arrays to make this much more efficient. Making our predictions. putting the output, the prediction out into another data source output, so that way we can see this stuff. And again, this will be printed out, the total number of iterations, the number of failures, the number of successes, and it'll also print out that training time from the actual training spot. So I'm just going to run this here. All this red is it setting up the use of the GPU to process this, since it's at least 10 times faster than a CPU. It's not the most efficient to run it on a small data set like this, but later on we're definitely going to be utilizing this. And okay, I forgot to mention the epochs in here. This is the number of iterations that each training set is going through the actual training process. So epochs 2 means that the same training file will be run twice. We're not entirely sure if that's going to be more efficient. We're still tinkering around with it. We've done some calculations of this sprint to test it, but on such a simple data set, it's relatively difficult to get good information. So here you can see the first data set's gone through. Our loss function is printed here at the end. The lower the number, the better. It means you're getting closer and closer to the correct value. So 0.08 starting off is pretty good, but you see we got it down to 0.01. The second iteration is much smaller. And here are the test results. Training times, 3.2 seconds, 93 successes, 7 failures total, and your success rate. So 99.3% for this is, we think it's pretty good. It's not the same every time, as you will see there. I actually think that 97% is one of the worst runs I've seen. But I mean, we can change these layers in here. I mean, we could go down to 2 and run this. And you see it's 98.9, still pretty good. We can change the epochs if we want to higher. In practice, that the results are mildly sporadic. We're still not sure the most efficient. Well, that was pretty good. The problem is it took almost 7 seconds to train the model, and that's going to be an issue later on when we're putting tons and tons of data into this training model. These seconds are going to turn into days quickly. So to wrap this up, that is pretty much our artifact. We're all very pleased with the progress we've made considering where we started. And yeah, that's it. Thank you.